We are in section A.2, factoring polynomials and solving systems of equations. The first property that we're going to discuss is the distribution property, and it's written a little different here just to kind of show what this means. And so it's like if you had 3 of these combo orders, which were 2 tacos and 1 soda, that means that we'd have 3 of those combo meals, or we'd have 6 tacos and 3 sodas. And another way to think about that is 3 times 2t plus d, and distributing that, and you would have 6t plus 3d. And I use these little rainbows to show that it needs to go to every single thing inside the parentheses when you distribute. And again, we're multiplying that number 3 to everything in the parentheses. So the example right below says 3x times 2x squared minus 4x plus 1, and it says to multiply these. And so we need to distribute our 3x to all 3 of those terms in the parentheses. And so from here, we get 3x times 2x squared, which is 6x to the third, minus 3x times 4x, which is 12x squared, and then 3x times 1, which is just plus 3x. The second example says 3x squared y times, and we need to distribute that to everything in the parentheses, so times 16x squared and minus 2xy squared. So we have 3 times 16, which simplifies to 1/2. And then we have x squared times x squared, which is x to the 4th by adding those exponents. And we have a y minus, we have 3 times 2, which would be 6. Combining our x's together, we have a 2 x's out in front of the parentheses, 1 inside, and adding those exponents together would be x cubed. And then we have a y cubed also. The next topic that we have on here is multiplying a binomial by a binomial, so 2 terms by 2 terms. They also, a lot of times in an algebra class, will call this FOIL. And so using that first outer in there and last, which is symbolized down here in the diagram. The example right below says to multiply. Part A says 2x minus 5 times 3 minus x. So 2x times 3 would be 6x. 2x times negative x would be negative 2x squared. We have a negative 5 times 3, which would be negative 15. And negative 5 times negative x, or positive 5x. From here, we need to combine our like terms. I'm also going to write this in standard form, which means that I'm going to be going from the largest exponent down to the smallest, or to that constant term. So the largest exponent that we have is a 2, so I'm going to have a negative 2x squared. I'm going to combine 6x and 5x, which is going to be 11x, and then we have our constant term, which is minus 15. Part B says 4x minus 3 times 4x plus 3. And what you can notice about these terms is they're identical, except for one has a plus and one has a minus between those terms. And so let's see if anything special happens with this one. So we have 4x times 4x, which is going to be 16x squared. And then we have 4x times 3, which is going to be 12x. Negative 3 times 4x would be negative 12x. And then we have negative 3 times positive 3, which is going to be negative 9. If you notice, we have 2 terms that we can combine together that actually cancel out, that become 0. And so we're going to have 16x squared minus 9. And this example has a special name. This is called the difference of 2 squares. And we'll see the formula down below on the next page. So we can extend this idea of FOIL to larger polynomials, but it's going to be called a double distribution property. And so we're going to use the distributive property more than once. And so for this one example that's shown here and worked out, we are going to go ahead and multiply 5x times everything here in our second parentheses. And so you'll see that 5x and then everything in the second parentheses. Then we write the second term that we have, and I'll box that. So plus 3 times everything in that second parentheses. And then from there, we can use the idea of distributive property twice. and go ahead and keep working it out, combining like terms. The example right below says multiply 2x minus 1 times 4x squared plus 3x minus 1. So I'm going to go ahead and circle my 2x, and I have to multiply that to everything in that second parenthesis. So 4x squared plus 3x minus 1. And then I have a minus 1 here. So minus 1, and again times everything in that second parenthesis. So 4x squared plus 3x minus 1. From here I'm going to use that double distribution property and distribute my 2x to everything inside those parentheses there. And so we're going to end up with 8x cubed plus 6x squared minus 2x. And then also distribute my negative 1 to all three of those terms inside that parenthesis. And I'm going to get negative 4x squared minus 3x plus 1. From here I can combine my like terms, and again rewriting this with the exponents decreasing in power as we go. So I have 8x cubed. I have a 6x squared and a negative 4x squared that I can combine together and get plus 2x squared. I have a negative 2x and a negative 3x, which is negative 5x, and then a plus 1. Right below this, we have a square of the binomial, and you can see those formulas there. These are special cases. So for this, it's a plus b squared means that you have to write that base, which is a plus b twice, and then you'll notice from there we can FOIL this or multiply it out. Likewise, for the a minus b squared, we need to write that term twice and then multiply it out. Remember, you cannot distribute exponents to two terms or more than two terms inside the parentheses. So you'd have to multiply that base that many times. So we have an example right below that says multiply 2x plus 3 squared. So you can use those special formulas that are up above, but most students don't have those ones memorized. They just go ahead and write 2x plus 3 twice and then FOIL. So we have 2x times 2x, which is 4x squared, 2x times 3, which is 6x, 3 times 2x, which is 6x, and 3 times 3, which is 9. Again, combining those middle terms, you're going to end up with 4x squared plus 12x plus 9. And so you can see up above, it's the same thing as the a squared term, which would be 2 squared times 2 squared, which is the 4x squared. B, which was 3 in our case, and so 3 squared would be 9. And then 2 times a times b would be 2 times 2x times 3, which would be that 12x. So using those formulas allows you to kind of see it a little differently. But again, you can save yourself just by multiplying it out, writing that base 2 times and FOILing. The next set of formulas that we have down here are definitely ones that we need to memorize. We have the difference of 2 squares, and then we also have the sum and difference of cubes. So the difference of 2 squares we saw previously on an example on the previous page. So you have a squared minus b squared. This is equal to a plus b and a minus b being multiplied together, those two factors. And then we have the sum and difference of cubes. So we have a cubed minus b cubed, and you'll notice that right below it, the a cubed plus b cubed, the formulas look almost identical. The difference is going to be the signs that we have. And a lot of students remember this by SOAP. And so you'll notice that that first sign here, since this is a minus, the first one is the same. And then you'll notice that the second sign is going to be opposite. So again, that first sign was the same here, but then the second sign is opposite of what we had in the original part. So we had opposite. And then the AP stands for, if you notice, for both of these, they're both positive. So it's always positive. So these are special cases and special formulas to make sure that you know. They're going to come in very handy as we go through the course. So right below this, it says steps for factoring a trinomial of the form ax squared plus bx plus c. And I'm going to go ahead and use what's called the x method. I also want to say that you can always try guess and check. And so I'm going to use this method when guess and check is just too difficult. And so we're going to be given ax squared plus bx plus c. Normally guess and check is very simple to do if a is just 1, so that term, the x squared, the coefficient in front of it would just be a 1. So I'm going to go ahead and draw my x, since this is called the x method. I am going to multiply a and c together, and that's going to go up in the top of my x. And then I'm going to put b, that middle term, down in the bottom. From here, I need to think of two values, and I'm going to put those two values there in those blanks that are going to multiply to a times c and add to b. And since my middle term here is an x, I'm going to go ahead and put x's with both of these. And from here, I'm going to write ax squared, which is that first term that we have. And then I'm going to write bx, but a little differently. I'm going to use those two values that we just came up with. So those two blanks that we have that are over here in my x method. And then I'm going to write my plus c. From here, I'm going to group. So we have 4 terms. I'm going to group those first two together, the second two together, and I'm going to factor out a GCF for both of these. And then we're just going to keep going from there. So we'll work on some examples on the next page. The example on the next page says factor completely and check your answer. And so for this example, it says 5x squared plus 11x plus 2. And so you might be able to use the guess and check method for this, since 5, that leading coefficient, only has two values that multiply to give you 5, so 1 and 5, so it makes it a little bit easier. However, since we just talked about the x method, I'm going to go ahead and do that. So if you're able to use guess and check, that's great. See if you can get it on your own. But writing our x method, first thing to note is that I have no GCFs. I have a 5, 11, and a 2, and there's no common factor that's going to go into those. I also only have x factors in 2 of those terms and not the last one. So I'm going to multiply a times c, which is 5 times 2, and I get 10, and I'm going to put 11 at the bottom. So now I need to think of two terms that multiply to 10 and add to 11, which would be 10 and 1. It doesn't matter if you write the 1 first and the 10 second. It's going to work out to be the same answer. I'm also going to go ahead and put an x in here, since that was that middle term. So writing this out, I'm going to have my first term, which was 5x squared. I'm going to write down my two values that I just found. They're both positive, so plus 10x plus 1x. And then I'm going to write down that constant, which is plus 2. So if you notice from here, if you were to simplify, you would get the original typed problem, because you can combine 10x and 1x and get 11x. From here, I'm going to break this up into two pieces. That first part, the 5x squared plus 10x, I'm going to look for a GCF, which is going to be 5x. And then factoring that out, I'd be left over with an x and a 2. Likewise, I'm going to do the same thing for the second pair of terms. There's nothing in common, and so whenever we have this, we're going to go ahead and factor out a positive 1. Doing that, I'm left over with an x plus 2. These things that are in the parentheses, these factors, need to be matching, and they are. That means that we did this correctly. If they're not, then obviously something bad happened along the way and you need to go back and check your work. So I'm going to go ahead and factor out the x plus 2. And factoring that out, I'm left over with a 5x plus 1. And we can check this by multiplying this out. So if we were to FOIL, we would have 5x squared plus x plus 10x plus 2. Combining those middle terms, we get 5x squared plus 11x plus 2. And that checks with what we were given up above. For B, the next example, we have 4x squared minus 12x minus 16. And I notice that I have a GCF that I need to factor out before I even begin this problem. That GCF is 4. And so taking the 4 out, I have 4 times x squared minus 3x minus 4. And I'm going to go ahead and see if I can use that guess and check method. Makes it a little bit easier, since now that I factor out the 4, the coefficient now in front of the x is a 1. And so I'm going to go ahead and write that 4 down, and then I'm going to go ahead and put two sets of parentheses here. And so the first thing is, what multiplies to give me x squared? Would just be x and x. And then there's a couple options for what's going to multiply to give me this negative 4. It could either be 4 and 1 with something being negative, or 2 and 2 with something being negative. It obviously cannot be positive 2 and negative 2 because that would be that difference of squares and we wouldn't have a middle term. So I'm going to go ahead and try 4 and 1. I'm also going to look at this sign for the middle and notice that it's negative, so that means the larger value would have to be negative here. And so if you ever use guess and check, it really stresses that checking part. And so I'm going to go ahead and multiply this back out in my check to make sure I did this correctly. If the guess and check is not something that you're used to, you can still use the X method. It does take a little bit longer, but it is going to give you the same answer. So checking this, we still have a 4 out in front, and I'm going to go ahead and multiply my x minus 4 times my x plus 1, and we get x squared plus x minus 4x minus 4. I'm going to go ahead and combine my like terms. So we have x squared minus 3x minus 4. Distributing through my 4, I have 4x squared minus 12x minus 16, which checks to what we had up above. So part C, I'm going to go ahead and circle, and we'll look at that one together in class. And then going on and looking at the next example, which now only has 2 terms, which is 9x squared minus 16y to the 4th. Normally, whenever we have something like this, we have to think of those special cases that we just talked about. I do not have a GCF on this. However, because I have 2 terms, it must be a difference of squares. So I'm going to go ahead and rewrite this. 9x squared is the same as 3x squared. And then we have minus, and then 16 would be the same as 4y squared squared. So again, you can check that using those exponent properties. From here, we're going to use our difference of squares, which is now going to be our 2 factors, which is 3x and 4y squared. And one of these factors will have a minus, and the other one will have a plus. From here, we can check this by FOILing this out. And so we would have 3x times 3x, or 9x squared. Then we have 3x times 4y squared, which is going to be positive 12xy squared. And then negative 4y squared times 3x is going to be negative 12xy squared. And negative 4y squared times positive 4y squared is going to become negative 16y to the 4th power. From here, you'll notice that the 12xy squareds would reduce to 0, and so we're left over with 9x squared minus 16y to the 4th, which checks to what we had up above. So again, making sure you know those formulas is key. Part E says 8x cubed minus 1. So it looks identical to what we just did. However, you'll notice that I don't have squared values in there. I have cubes. And remember, we have the sum and difference of cubes. This one is clearly going to be a difference of cubes since we have a negative sign in there between our terms, or a minus sign. And so to rewrite this first term of 8x cubed, I'm going to rewrite this as 2x to the 3rd power. And 1 is always itself raised to any power. So I'm going to say 1 raised to the 3rd power. So remember, with these, the difference of cubes, or the sums of cubes, we're going to use the idea of SOAP. And SOAP works as, so I'm going to go ahead and write down my terms first, and then we'll put those pluses and minuses in there. So it goes ahead and we put our first term here and our second term here. So our terms are 2x and 1. Then for the trinomial part, the 3-term part, we're going to go ahead and square 2x, which is going to become 4x squared. Then we multiply 2x times 1, which is 2x. And then we square that final term, which is 1. And again, those formulas are listed previous page, so make sure you know those. Then we're going to go ahead and use the idea of SOAP, which is going to be the same sign, the opposite sign, so a plus, and then an always positive sign. So from here, we can check this. I'm going to do that double distribution. I need a little bit extra room, so I'm going to start my check up above. So 2x times 4x squared plus 2x plus 1 minus 1 times 4x squared plus 2x plus 1. Distributing through the 2x, we get 8x to the third plus 4x squared plus 2x. Distributing through that negative 1, we get minus 4x squared minus 2x minus 1. You'll notice that your 4x squareds sum to 0 and your 2x's are going to sum to 0, and we're left over with 8x cubed minus 1, which checks to what we had up above. So the next example, F, I'm also going to circle, and we'll look at that one together in class. And then G, down below, says 5x to the 6 minus 80x squared. And for this one, I do notice that we have a GCF that we can factor out before we even begin this problem. So 5 goes into both 5 and 80, and both terms have an x squared in them. So factoring out my 5x squared, we're going to be left over with, so taking 2 of those x's out, we have x to the 4th minus, and taking 5 out of 80, we get 16, and then those x squareds are already taken out. And so again, we have the difference of squares here. So I'm going to go ahead and write my GCF, 5x squared. The difference of squares is going to be x squared minus 4 and x squared plus 4. And you'll notice that this x squared plus 4, we can't go any farther, but we can for the x squared minus 4. And so I'm going to go ahead and write 5x squared. I'll put the x squared plus 4. And then I'm going to go ahead and take my x squared minus 4, which is difference of squares again, since 4 is 2 times 2. And so we're going to have x plus 2 and x minus 2. And that's as far as we can go on this. It's factored completely. Again, to check this, we have a 5x squared times x squared minus 4. Multiplying x plus 2 times x minus 2, we are going to get an x minus 4. Multiplying the x squared plus 4 times x squared minus 4. We still have that greatest common factor out in front, but we'll even have x to the 4th minus 16. And then again, distributing through that 5x squared, we get 5x to the 6th minus 80x squared, which checks to what we had up above. Part H, we have 4 terms this time, so I'm going to go ahead and circle this one, and we'll look at that one together in class. Again, remember the first thing you should always do is factor out your GCF. So the summary of the steps for factoring any polynomial is given here. So the first thing is to factor out your GCF if there is any. 2 says if the polynomial is one of the special cases, use the special cases formulas. This would be like our sum of difference of cubes or the difference of squares. 3 says if you're given 4 terms, factor by grouping. 4 says if neither step 2 or 3 pertains to the problem, then use that X method that we talked about. Or you can try the guess and check. 5 says to make sure that the factors have no common factors. If they do, factor them out. And then 6 says to check your answer by multiplying out those factors. So the next thing that we have is a rational expression or a fraction. And so this is a quotient of 2 polynomials. A rational expression is simplified when the numerator and denominator have no common factors other than 1. So if they have a common factor, we can reduce those to 1. So for example, 6 over 9, we are going to rewrite this as 2 times 3 over 3 times 3. And factors are being multiplied together. And so these 3's you can see would reduce to 1. And this fraction would reduce to 2 over 3. So we're going to extend this idea to rational expressions that are going to involve polynomials in the numerator and in the denominator. So the steps to do this is we're going to factor both the numerator and the denominator as completely as possible. Divide both the numerator and denominator by any common factors, so reduce those out. So the first example that we have says simplify x squared minus 3x minus 18. So I'm going to go ahead and simplify the numerator. A lot of times the denominator kind of gives you a hint of what you can use to factor this. And since our leading coefficient is 1, I'm going to go ahead and try to factor this by our guess and check method. So I'm going to put x's here since those are the only two things that multiply to give me x squared. And then for 18, we have a couple different options. It could be 1 times 18, 2 times 9, or 3 times 6. Since my middle term is a 3, I'm going to use my 3 and my 6. And it's also helpful to look at that denominator in this rational expression. And you'll notice that we have a minus 6. So it kind of gives me a little hint that that's probably a minus and this would probably be a 3. So foiling this out and multiplying and checking to make sure I did this right, I'd have x times x, which is x squared. I would have negative 6x plus 3x, which sums together to negative 3x, and then 3 times negative 6, which is 18. So if you need to do that checking work on the side, go ahead and do it. And so if you notice, we have a common factor in our denominator and in our numerator. That common factor is x minus 6, and so that x minus 6 over x minus 6 is just 1, or it simplifies out. And so we're left over with x plus 3. So likewise for b, we have 4x to the fourth minus 4x cubed over x to the fourth minus x squared. So factoring out our GCF, we are going to have in the numerator 4x cubed, and we're left over with x minus 1. And then in the denominator, we're able to factor out an x squared, and we are left over with x squared minus 1. So the numerator is 4x cubed times x minus 1, and then the denominator, we can continue to factor this as x minus 1 times x plus 1 using that difference of squares. And so from here, reducing this out, our x minus 1s would simplify. Likewise, our x factors would simplify too. So we have x squared here, and 3x is up above, so I'm going to cancel out 2 of those. And so left over in the numerator, we have a 4x, and in the denominator, we have an x plus 1. So right below this, it says multiplying and dividing rational expressions. So when you multiply fractions or rational expressions, you just multiply the top times the top and the bottom times the bottom. So multiply those numerators together and multiply those denominators together. You can also simplify this either before or after as you go through the problem. Division, that first fraction would stay the same. And we're going to switch our division to multiplication. And then we're going to do the reciprocal. So if you notice that second fraction here, r over s, is flipped, and we now have the reciprocal. From there, we're going to multiply our numerators together and our denominators together, and this is provided that the denominator is not going to be equal to 0. So factor and the equivalent expression property of rational expressions are used in the multiplication and division of rational expressions. The example on the next page says to simplify, and so in order to do this, we need to factor and reduce any common factors that we have. So the first thing that we do have is x minus 2 over 3 minus x times, and we are able to factor that second fraction here, and we have x squared minus 9, which is the difference of squares, so factors to x minus 3 and x plus 3. Likewise, the denominator is x squared minus 4, which is again the difference of squares. So we have x minus 2 and x plus 2. And you'll see that we have an x minus 2 factor in the numerator and in the denominator that we can reduce down. And then you'll notice that we have a 3 minus x, which is actually opposite of the x minus 3 in signs. And this happens quite often, and in order to deal with this, we're going to go ahead and just factor out a negative, and I'll do that on that first term here. And so factoring out that negative, it would actually switch my signs, and this would become a negative 3 and a positive x. Then you'll notice that we have a negative 3 and a positive x here, and a negative 3 and a positive x also up here. And so those are the same factor, those would reduce or cancel out. And so we are left over with an x plus 3 in the numerator and an x plus 2 in the denominator. We also have this negative sign here that we can't forget. So I'll go ahead and put that in the front on the numerator, but again, you could put it either in the middle in the numerator or in the denominator. It's the same thing. If you would like, you could distribute the negative too. That's an equivalent answer. Part B, I'm going to go ahead and circle, and we'll look at that one together in class. Right below, it says steps for adding and subtracting rational expressions. So the first thing is to factor, cancel any common factors if possible, look at the denominators. Remember, in order to add or subtract fractions, you have to have a common denominator. And so if the denominators are the same, then great, you could just add and subtract the numerators and place the result over that common denominator. And if the denominators are different, then you have to find the LCD, change the expression according to the LCD, and then add and subtract the numerators, placing the result over that common denominator. So if the denominators are different, you have to get a common denominator. So you need to get a common denominator. And then again, you would try to reduce if possible, and then leave the denominators in factored form. You don't have to multiply them back out. So we have some examples right below this that say add or subtract the rational expressions. And so if you look at the first one, you'll notice that the denominators are not the same, but I can factor this. So I have 3x minus 1 over, again, that difference of squares, so we're going to have x plus 2 and x minus 2, minus, and then we have 2x plus 1 over x minus 2. And so right now they both have an x minus 2 in the denominator. However, I am missing that x plus 2 in the denominator for the second term. And so I'm going to have to multiply both the top and the bottom by an x plus 2. I'll just go to put some parentheses around these. And so from here, we are going to have a common denominator of x plus 2 and x minus 2. And I'll go ahead and put the whole thing over that. Then we have a 3x minus 1 minus 2x plus 1 times x plus 2. And so from here, we need to multiply out the 2x plus 1 and the x plus 2 and combine our like terms. And so if we were to do that, you would get 2x squared, and then we have plus 4x plus x and plus 2. And so from here, we would have 3x minus 1, and then I'm going to distribute my negative sign that I have here to every single term in there, and then also combine these two middle terms. So we're going to have negative 2x squared minus 5x minus 2 all over my x plus 2, x minus 2. And then from here, we're going to go ahead and just combine our like terms. Again, writing this in standard form. So we have a negative 2x squared. We have a 3x minus 5x, which is going to be negative 2x. And then we have a negative 1 and a negative 2, which is negative 3, over x plus 2, x minus 2. And looking at that numerator, it does not seem like we would be able to factor that. You can check again by using the x method or guess and check to see, and you'll realize that we can't. So this is as far as we can go by adding and subtracting this rational expression. Part B says 5x over x minus 2 plus 2x over 2 minus x. You'll notice that the denominators are almost identical, but they're off by a sign. And we saw this earlier, so I'm going to go ahead and factor out that negative in the second fraction, and that's going to become a negative 2 and a positive x. Now the denominators are identical. It might be helpful, though, to rewrite it just so you can see it a little bit better. And I'm going to go ahead and put the negative up on the numerator, and I'll rewrite my terms, and I'll say x minus 2 rather than negative 2 plus x. And so from here you can see that those denominators are the same. And then combining our numerators of 5x plus negative 2x, we would get 3x. And from here we're unable to simplify anymore, so that would be our final answer. Right below this we have solving quadratic equations by factoring. And there are other methods too to solve quadratic equations, but this is the first one that we're going to look at. So the first thing you need to do is you need to write the equation in standard form. and one side needs to be 0. Second thing is to factor the non-zero side of the equation. You're going to set each factor to 0 and then solve the resulting equations. And the big thing here is to check. So the first problem that we have says solve the equation and check your answer. So we have x times x plus 8 equals 33. And again, remember, one side needs to be equal to 0. So I'm going to distribute my x and get x squared plus 8x. And I'm going to subtract 33 also. So that way one side is going to be equal to 0. From here, we need to solve this. And you can solve by either guess and check, like we saw earlier, or by the x method, which we also saw earlier. I'm going to go ahead and use the guess and check method, and so the values that multiply to 33 are only 1 and 33, or 11 times 3. So we're going to have an x, and I'm going to go with the 11 and 3. My larger term needs to be positive because my 8 is positive, and I'm going to have a minus 3. Again, checking this, if you did, you would have x squared plus 11x minus 3x, which would give you the 8x, and then minus 33 equals 0. So we have x plus 11 equals 0, and x minus 3 equals 0. And then solving this, we get x equals negative 11, and x equals positive 3. So from here, we do need to check, and so in order to check, we're going to substitute these in. And so the first one we have is negative 11 times negative 11 plus 8 equals 33. And so we're going to have negative 11 times 3 times negative 3 equals 33. So we get 33 equals 33 and check. To check our second one, we're going to have 3 times 3 plus 8 equals 33. So we have 3 times 11 equals 33. 33 equals 33. Check. So make sure to check that all of your solutions work for the problem. For B, you'll notice that this one already has one side equal to 0 and it's factored, which is really nice. We have 3 factors here. We have x, x minus 5, and 3x plus 4. So I'm going to set each of these equal to 0, so the first one's solved already for us. And the last one would be 3x plus 4 equals 0. So we're going to get x equals 0, x equals 5. Then solving the second equation that we have written that we need to solve, we'd subtract 4 and divide by 3. So we will get x equals negative 4/3. I'm going to go ahead and say you can check on your own for this one, but as you plug each of those factors in, you'll notice that you do get a 0 on the left side, and 0 times anything would equal 0. Part C, I'm going to go ahead and circle, and we'll look at this one together in class. Sometimes it's difficult to factor these and solve them, and sometimes the solutions are not nice and easy. And so a way to kind of work around this that you can use would be the quadratic formula. So definitely a formula that we need to know. And so the solutions to a quadratic equation of the form ax squared plus bx plus c equals 0 can be found by using the quadratic formula. So the quadratic formula is going to start with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the next example says solve the following by the quadratic formula. And so going ahead and making sure one side is equal to 0, which we need to have. We have 4x squared minus 8x plus 1 equals 0. And then to find our values of x, we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then just slowly simplifying this, we have negative 8, which would be positive 8, plus or minus the square root of negative 8 squared is 64 minus 4 times 1 is 16 all over 8. From here, 64 minus 16 is going to equal 48. So we have 8 plus or minus the square root of 48 all over 8. And then to simplify 48, 48 is the same as, if you think of perfect squares, 16 times 3. And so we know that this is going to be 8 plus or minus the square root of 16 times 3 all over 8. And we know the square root of 16 is going to be 4. So we have 8 plus or minus 4 square root of 3 all over 8. And so from here, you can simplify this. You're able to say that this is the same thing as 8 over 8 plus or minus 4 rad 3 over 8, separating that common denominator that we had already found. And 8 divided by 8 would just be 1, plus or minus 4 over 8 would become 1 over 2, and we also have a radical 3 in the numerator. And so these will be our solutions. This is what x again was equal to. Part B says x squared plus 7 equals 2x. And again, we need to rewrite this so one side is equal to 0. And now using our quadratic formula, it's also good to note that this is not able to be factored, like with part A. We weren't able to guess and check. Nothing multiplies to 7 and adds to -2. And using the x method wouldn't help either. So we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So from here we have 2 plus or minus the square root of, and we have -2 squared, which is 4, minus 4 times 7, which is 28, all over 2. And continuing to simplify this, we have 2 plus or minus the square root of, and 4 minus 28 is -24, all over 2. And this is an issue. So we're not allowed to have a negative inside a radical for real solutions. Those are going to be our imaginary solutions. And for our class, we only deal with real solutions. And so this is not real, so we are going to go ahead and say that there's no solution to this. So right below this, it says steps to solve a rational equation. So step 1 is going to be to eliminate all fractions. Option 1 is to multiply the entire problem by the least common denominator, or the LCD. And then option 2, you can cross multiply. Option 1 will work for any problem, but you can only cross multiply if you have one fraction equal to one fraction. That is if the fractions are proportional. It says, note that when solving rational equations, all fractions should disappear after the first step. From there, you're going to do step 2, which says to simplify the resulting equation. So you might need to distribute, combine like terms. Step 3 says to solve the simplified equation. If the simplified equation has any higher power, such as an x squared or x cubed, you can solve the equation by getting it equal to 0 and factoring. If the simplified problem does not contain any higher powers, then solve for x by getting x's on one side and the number on the other, so isolate the variable. Step 4 says check each solution. Substitute each solution into the denominator of the original equation. Reject any solutions that cause the denominator to equal 0, because this makes the problem undefined. So right below this we have some examples. The first one says solve, and we have x squared over x minus 6 equals 36 over x minus 6. And so you are able to cross multiply on this one. However, I'm going to go ahead and use that first property that we had up there, option 1. And I'm going to multiply both the left and the right side by that common denominator, which is the same, which is x minus 6. And remember, in algebra, whatever you do to one side, you have to do the other. So the x minus 6's would cancel on the left as they would on the right. And then from here I'm left over with x squared equals 36. And I'm going to go ahead and move my 36 over to the other side. So one side equals 0. and factor this. You could have also used the square root property to solve this, but from here you're going to get x equals 6 and x equals negative 6. But do they both work? So you need to check these, and if you do, you'll notice that when substituting in x equals 6, it's not going to work. We get a 6 minus 6, which causes our denominator to be 0. So this is not a solution. It's a very big deal to sit there and check all of these, because a lot of times many of them or all of the answers will not actually work. So part B says 3x over 4 plus 1/2 equals 2x minus 3 over 4. So our common denominator would be 4. And I'm going to go ahead and multiply everything by 4. You need to multiply all your terms by 4. So you'll notice they will reduce here, they'll reduce here, and then 4 over 2 will be 2. So we get 3x plus 2 equals 2x minus 3. And you'll notice that this time we don't have any higher powers on our variable, and so we're just going to solve this by isolating our x. So I'm going to subtract 2x on both sides, and I get x plus 2 equals negative 3. And then subtracting 2 on both sides, I get x equals negative 5. You'll notice that in this example, there is no variable in the denominator, so we don't have to stress about it not working and not being a solution like we saw in the previous example. So we get x equals negative 5. You can also always check this again by plugging it back into the original problem. So the next example that we have is 2 over x plus 3 minus 5 over x plus 1 equals 3x plus 5 over x squared plus 4x plus 3. And so for this, I need to first factor my right side of my equation. So I'm going to have 2 over x plus 3 minus 5 over x plus 1 equals 3x plus 5 over, and then factoring x squared plus 4x plus 3. Guess and check. Multiplies to 3 is just going to be a 3 and a 1. Everything is positive, so I'll put my pluses in, and then you can check that to make sure that we do get the x squared plus 4x plus 3, which we do. You'll notice that your common denominator is going to be x plus 3 and x plus 1, and so we will need to multiply that to every single term. So I'm going to squeeze that in on all these terms, so x plus 3, x plus 1, x plus 3, x plus 1, and x plus 3, x plus 1. From here, your x plus 3's are going to reduce in the first term, and we get 2 times x plus 1. Then we have our x plus 1's are going to reduce. We have minus 5 times x plus 3. Your x plus 3's and your x plus 1's will reduce on the last term, and we just get 3x plus 5. From here, I'm going to distribute, and so we have 2x plus 2 minus 5x minus 15 equals 3x plus 5. And then I'm going to go ahead and combine my like terms, so I have 2x minus 5x, or negative 3x, and then minus 13 equals 3x plus 5. I'm going to go ahead and subtract 3x on both sides. And I'll also add 13 on both sides to kind of do 2 steps in one. So we get negative 6x equals 18. Dividing both sides by negative 6, we get x is equal to negative 3. So we have a solution, but we also still need to check this into that original typed problem at the top. And you'll notice that that first fraction that we have, that first expression, that first term, if you substitute in negative 3, you're going to have 2 over negative 3 plus 3, or 2 over 0, which is no solution. So this does not work. So this makes the denominator 0. So this is no solution. So we have another one on the next page that I'm going to go ahead and circle, and we'll look at this one together in class. The last topic that's discussed in this section is systems of equations. And so a system of equation involves two or more equations that have the same variables. And we have a few different methods for solving them. One is graphically, one is substitution, where you would isolate one of the variables and substitute it into the other equation. And the addition, or also called the elimination method, where you line up those variables and then you're going to subtract those two equations to eliminate one of those variables. And so the first example on here says solve the system of equations algebraically. So this means either by using substitution or the addition method. And then check your solution, which again is a good thing to get in the habit of. So for the first example, I'm going to go ahead and use that elimination method. My x's are lined up, my y's are lined up, my equal signs are lined up, and then I have just a constant number on that right hand side of the equation. And I'm going to go ahead and just get rid of the y variable. You have options here, but to get rid of the y variable, I need it to be the opposite of 2y. So my first equation I'm going to multiply by -2. And so we get -6x minus 2y equals 2. And the first equation changed by multiplying every single thing by -2. My second equation, I'm not going to multiply anything by it. Sometimes in some of the examples, you might have to multiply both of the equations by a constant, but for this one, we didn't have to. So from here, I'm going to combine my two equations. You'll notice that my y's are going to go ahead and reduce, and I have -6x plus x, or -5x, equals, and then we have 2 minus 12, or -10. Dividing by -5 on both sides, I get x is equal to 2. So this is half of my solution. To find my y value, I'm going to pick one of the equations and substitute that back in. So I'm going to use the first equation. I have 3x plus y equals -1. And I'm going to substitute in x is 2. And so I have 6 plus y equals -1. And then subtracting 6 on both sides, we get y equals -7. This is the other half of my solution. You do need to write these as an ordered pair. So we have 2 for my x, -7 for my y. And that would be your solution. To check this, you would have to substitute in x is 2 and y is -7 to both the top and the bottom equation to check to make sure that those work. And then we have b, which I'm going to go ahead and circle. This one's a little bit more involved. If you notice, they're not linear. The second equation is linear, but the first one is not linear.